Are we live yet? Hello everyone. I hope I announce the stream correctly. Unusual time. Let me open a booster even though it's not very late. I'm still a little bit dizzy from busy weekend, but anyways, I had a little nap earlier. Today and yesterday we unboxed a lot of new stuff. We have a stack of blades, supercluster blades. Wait, not this one. We can pause that here. All right. Oh yeah, yeah. There is a stack of 15 new blades. 8,000 MCUs, and we have this board. Foo, you here? Nice. Yeah. So we have this board. I can do a Colombian head. I can make a Colombian head. I just need something on top here. 50 centimeters Mexican sombrero. And what we can do, oh yeah, so this was one of the boards that we received yesterday. Then we have, you can still see we have sunshine here. Oh, thank you very much for the donation, Fu. We tested our FPGA footprint yesterday. Oh no, my fingernails are off, but the connectors that I found on LCSC, you can see those. Today, no rambling, just making. The breakout board for the Tang Nano 25K. No, Tang Prima 25K, sorry. I forgot to place like an indicator which way around you plug it in, because it's symmetrical. You can plug it in wrong. Hey Rohan. Yeah, and at first it didn't seem like it's fitting, but then like boop. Hey Sonic. So this is correct. But I think, you know what? I know which way around. I think the text on the board and on the... No, the text on the board is... I can't tell. I need to find out. I need to change the design of like the silk screen to have that indicated. Are those high-speed connectors? What is the specified speed for these things? Certainly, the differential pairs. If we take a look at that, today we're not losing any time, peeps. We are just jumping right into our tag. Let me get you some lights. Put some light on that. Sombrero. Okay, so yeah, I routed the differential pair by hand. You can see the length is not matched here. So can't expect this MIPI lines to be performing very well in the end. I should have matched that. That's like 1 millimeter, 1.5 millimeter length difference here. But like with the jig that we made yesterday, that went really smoothly. Like placing this connector there. Wait, there is no focus for you. Here's focus. Can't get this off. Yeah, look at that. I'm wondering, there must be some sort of compliance in this connector, because you can never pull it like perfectly to 0.1 millimeter millimeters, because like the footprint, I think I will make the pads even shorter, because if we look closer, oh, enhance. Wait, oh, I can't enhance because I put the microscope quite high yesterday. Okay, let me enhance even more. Here. Can't enhance even more. I think pin pitch is 0.4, 0.5 millimeters here. Yeah. The reflection is confusing because it looks like it's not really well sorted, but it is. Yeah, no, that's all right. Yeah, it could be shorter by, I don't know, even like half a millimeter, so it would align itself better. This way we have too much space for adjustments. Yeah. All right, so that was that. And we needed for the next version of our sombrero board. I'm wondering if this, yeah, this paste is not still. I think I can still use the paste, but I also want some gloves, because yesterday got some sticky stuff on my fingers and then picked my nose afterwards. Anyways, is it tilted? My microscope looks like it's tilted in some way or form. It's weirdly out of focus on the right side. All right. Today's mission should be quite simple. Hey, Dutch Maker! Yeah, little boost. So, to have that nice. Oh, really? 20 gigabits per second. Amazing. Yeah, it's usually always on Wednesday, but like the last weeks I was on holidays. Yeah, this sombrero PCB, we need to assemble. It's not very complicated. We have like two MCUs. No, three MCUs, like two here in the corner and there in the corner, and a lot of through-hole connectors, 16 this time for the first version, and some XT60 connectors. So this is not very complicated. I think this is the bottom, this is the top. So a radius is 24 centimeters. It's FPGA race can go. Okay, you mean, Ron, this specific go-in? Because that's like the differential pairs. I mean, it has a lot of differential pairs, but those the gramophone. Hey, Natsu. Probably. I have like some tracks that are going around here. But the traces, I put them inside. I have only power traces on the outside, and there are like only 4 of those. This will be interesting to test that. Yeah, these boards were $450, and half of that was shipping cost and customs. That's a good test. I mean, for precision wise. Looking As a frisbee? Not yet. I'm reluctant because it's like $80 per PCB right now. MOQ? Yes. Yeah, I wanted only one, but they always produce a stack of 5, and then which is I can't imagine how can you use like a 5 millimeter high bit drilling through like stack of 5 PCBs at the same time and being still precise to the 0.1 millimeters at sizes like half a meter here. Anyways, today I wanted, I don't know, maybe it doesn't even fit, but I have like used stuff here. Okay, so this will be the connector. Oh, I have bent pins already here. Where is the bent pin? Here. Ah! Yeah, that's always like a stack of 5 PCBs, and they are made at the same time. That's why you never get like a different quantity, like multiple of 5s only. They stack up 5 boards and then drilling them all at the same time. Okay, so yeah, this is one of the Oh, we need to print a lot of those plastic interfaces. Oh no. Yeah, to stack the PCBs. Alright. Oh, everything is shaking. So today I started designing basically the frame or the case, because we have at the perimeter we have our power boards. Without transceivers. But it has MIPI. What is the specs of the MIPI interface? Tank primer 25. I would like to know what MIPI. Okay, 2.5 gigabits per second per lane. Features a hardcore 4-lane MIPI DeFi interface that is rated to reach up to 2.5 gigabits per second per lane. Streaming 1080p 30 fps MIPI CSI to camera like OV blah has validated a highly stable real world speed of 1.2 gigabits per second. Hey Jody. So what I want to achieve is some sort of fast communication between I don't know. I have no clue how the MIPI interface works. It's like a media interface, but can you use that to communicate between FPGAs? All right, so I tried to design. Okay, that's like the. That's the omnidirectional. Unidirectional. Oh. Is there no way of using it just as differential pair TMDS or whatever? Okay, where is it? Okay, so PCB here. Okay, we can see the PCB. The PCB would be inside of like very narrow 1 millimeter edge here, and then we have if you look from the side, we would have like 6 millimeters. That's 6 millimeters of space for any acrylic tube, and then we have what is it, 12 bolts of 10 millimeters each, and I would take 12 because I have one layer which is the power frame here. Why can't I see? Yeah, power frame, which would each of those segments here would contain a power board, which is this size actually. This is basically the frame of the supercluster, the ultra cluster. Sorry. I need to somehow mount this base in the end and put the blades in here on the connectors, and the blades are these here, the stack of blades. So that's, and what I wanted to do is to print now this huge frame. I have routed all the lines on my this is just a breakout board that has all the connectors, because the regular one, that one here that you can purchase, doesn't route out all the connections. It has like I mean, they connect other stuff to that, like JTAG and whatever. So this one doesn't have all the connections on the header here, and I wanted just something to test. So this is just a breakout and some additional power connectors here where you can connect power, and you just only need like one pin for 5 volts and then distribute it or whatever. It's so weird. This FPGA is a little bit weird because I mean, you don't need to supply 5 volts, I believe, but then you would need like the regulator that's on there wouldn't work. I don't know if you get your 1.1 volts or what's required there out of it. If you don't have we would need to test that if it also works if you only supply 3.3 volts to it. But I think the documentation says it's 5 volts supply, and then it does the power regulation there. Or you need to supply everything yourself. Anyways, I thought, all right, let's do that. And then to connect everything, we will just use pegs or bolts or whatever of 10 millimeters. We can use basic from the hardware store 10 millimeter aluminum tubes to stack all the layers of whatever we need to build this supercomputer up. And the issue is, unfortunately, I tried to quarter it, So if we take the quarter of everything, so that's the base frame. We have the base ring, which is just something that to connect things. So a quarter of that. We have quarter of the power. Quarter, let's not show that. Okay. What is PogChamp? Okay, I thought I can print it. It's perfect. Okay, let's quarter it, and then we can just use the ring to stack multiple next to each other to have that working. Unfortunately, emoticon. Yeah. Unfortunately, maybe I should use more than this. Unfortunately, when I underestimated the size because I thought, oh, my print bed isn't 48 centimeters, so I quarter it, and the result is this here. Error. Yeah, no. Yeah, I can rotate it and no. I think I need to cut it in thirds or whatever. But cutting it in thirds is no, in 6 parts is gross. Okay, 6 is not a bad number. It's not a prime. Dang. All right. So let's take. How do I cut it so I can still bigger bitte. Okay, first of all, I need to keep the faces as they are right now. So I guess I will cut it in pieces like this here. So it's not quarter, it's, yeah, in 6 pieces. Alright, this will be interesting. Was wird das? Das wird das Gehäuse für mein Ultra Cluster. Die Größe ist leider ein bisschen, das ist jetzt zum Beispiel die Hautplatine. I really thought it's not that big, but it's bigger than expected. Well, in the end, it needs to fit like 65,536 MCUs on that. So, all right, it needs to have some size. Okay, how do we cut it in? We need an arc. Planet. Das wird was, ja. Wird das was? Das wird was, okay. What we can do is to get, how do we cut it? So I did an intersection with this cube here, which is not perfectly on line here. It's like 0.1 millimeters. We would need to cut it in a section like that. Yes, but how do you get perfect 60 degrees here? We need a tangent of what is tang 30, and then tangents, where is it? Five, 7. What's the size of that thing? Oh, this is, we need to calculate minus 27 times 27. It's 1558. 55, 15. No, that's not. I'm getting something wrong. It should be tangents here. Why do I get 15? 27, 30, 0. Wait. Huh? Oh, wait. Yeah, I'm wrong. Okay, now that's perfect. 15 minus 15 point. No, wrong axis here. 15.5. What is it? 59. 59. Yes. Ooh, math. I can math. This is the third. Not the third, or the sixth of. I guess this should be right. But this will never like hold if I have only like 2 bolts here. I need at least, for the stiffness, I need at least 2. Oh no. Shit. This won't work. We need some groove or something. Tongue and groove for that to work. Otherwise it will just fall apart. It will be very weird if we do it like that with the pegs. Yeah, need a tongue and groove, but we need one that is like a pyramid, so it's 3D printerable. High-speed connector STLs. Live what? What is STL? Huh? High-speed connector? 3D model for, huh? What? You're confusing me. High-speed connector. Okay, we will do a groove so we can stack it. But how do we do it? I need a cylinder for that. Oh no, this is completely something different. This is not a dimension. I have like this I used the models to design like to start a design of the main board, but this preliminary main board doesn't use the FPGAs at all. I just need a frame where to put this on and connect everything and put the mount the power boards around it and everything. So this is something else. I'm all over the place. This is ADHD mode, the deluxe. And now I'm designing something stackable, where I can use like rods, 1 mm diameter rods, and then stack like the frame, because that we need to fit this on the 3D printer. And if I rotate it by 30 degrees and the next part that I stack, it will be very oh, okay. I have on my okay, that was a joke. Now I get it. The Bamboo Lab has a 0.2 millimeter nozzle mounted, so actually that could work. But it will take a little bit longer to print though. Alright, so this part should be a little bit smaller, but now we need to adjust the groove. So how do I do the groove? I think I will do the groove a different way. We can do the groove. Let me create a cylinder maybe. Nah. Yes. Create cylinder. Yeah, or this is not okay. Vertices 128. Depth is, I would say, what kind of depth do we need? Like 4 millimeters. That's like 0.4, because this is in centimeters. Everything. Location. Okay. 0, 0, 0. Radius will be where are we? 25. A little bit more. 26. No, 25. Okay. Okay, that's the 20. That's a little bit much. 25 point, since it's 4 millimeters. Is 4 enough for the tongue? Okay, let's do 6. So 8. 5.58. Okay. And this should be alright. Depth 0.4. Vertices. Okay, I can just duplicate it and wait. Oh, this 1.6. Why is it 6? Didn't I want to do 8? Five. What's with 4? Is this correct? Okay, let's boolean it. Now we should have a ring. Okay, let's extrude this. 4. 0.4, okay. That's an extrusion, but how do we make it I think this is not good how I'm doing it. Let me edit this. Edge loop selection. Oh. At this point, I think it would be easier to do it with actual cut software. Circle select. No. Select. Open SCAD. You mean where you write the text? Oh no, that's not a ring. Select add loops. Huh? Oh. That doesn't work. This is stupid. Can't even select the loop. I need the top to be narrow. Like I would expect this edge loop to be selected when I do that. Select. Inner region. This one works. Alright. Why doesn't the other one work? If I scale this, or can I select this one as well? Let's do that. Oh no. I want to select this and that. Yeah, the inner doesn't work because it's cut. Okay. New plan. Revert everything until we are done. No more revert. Oh, wonderful. Okay, let's delete it. And create new. Yeah, Alexa. No. We have no time for that. I need to have that finished this week. Alright, so we take that, we edit this thing. We take these vertices. Now let's select the vertices. Okay, and then we delete them. Boop! Now we have this here. What we can do even is we can just leave the ring Okay, so we have now this ring loop, and what we can do is we can copy that. Okay, and then scale it to, what was it, 554, 54. Okay, so we have these edges. Now we can duplicate that again and do 50. Yeah, 51. Was it? Yeah, that's the center. Raise it a little bit. Duplicate that. Did we duplicate it? Is it there? Minus. Okay, and now we will face it. So we join these 4 edge loops. Is it? Yeah, they're joined. Now we can select those. Wait. Loops. Okay, select and then face it. Boop! Wrong. Okay. Let's try again and just select one and then face that. Now we will do like that. Oh. Select edge loops and try face again. Yeah, and now it works. Okay, and we do the same. Do the same here. Now it knows how to face that. Select edge loops. It's overcomplicated. People are just face palming looking at this, but all right, just make it work. Let's just do this. Okay, and then face it. And face it. Okay. Now we should have something that we can use as a merge, and that looks weird. Huh? Huh? Yeah, I think we need to triangulate it. Hey, Holy Flame. Okay, mesh. Split, no. Face, triangulate faces, yeah. Yeah, otherwise this won't work. I can't even select the other one. I don't know where the center is. Here's the center. Triangulate faces. There's more. Here, this one. I don't know why Blender thought this is a good idea to keep it like a one face. Okay, makes more sense now. I hope. Okay, we have 4 quads here. Let's fix those quads. Face triangle. So it's at least everything is all right. Okay, let's save it. My case. Now we can combine that tongue and groove that's printable with our remaining design. Okay, how do we move it? Gasometer? What is a gasometer? Okay, I think I'm. This thing is. I thought it looks like Oh, that's all right. Like, but I think this is too high. I don't need it to be as prominent because that will print like 1 centimeter of height prints like another hour or two. I don't need it to be very high here, so let's keep it shorter, everything here. So this is, what is this thing? Oh, that's the PCB, yeah. That's the PCB. Then this is the base. Let's move it up. Ah, that was too much. Yeah, that should be enough. 5 millimeters should be plenty for retainer. Okay, that's that, and then we will also change the height here. Let's 2 centimeters should be more than enough for stiffness, and let's put that thing then. Oh no. Okay, 0. Huh? Oh, I see. Our origin is shifted slightly here. Move it more. Here, like that. Okay, so, and we need to subtract that. Oh, you can see that. It's a Boolean operation. And then we will subtract. Come on, here. Boop. If that works. No, it doesn't work. Yeah, it works. Okay. That worked. Let's hide that. call it groove. Okay, so groove is here. That will align everything. Let's, I don't know if you can see that. Maybe we'll start recording. Okay, that should be the first part, and we need to print it 6 times. 6 times, and it won't hold until we do this one. Let's move it up. 3.5, and we need to combine that with the groove union groove. Oh no, yeah, okay, sort it. Bloop. Here we go. So there is a groove, and then we can basically stack that with those parts. We can print as many as we need to do whatever. Okay, well, let's export it and see what happens. Base frame, and this is base ring. And yeah, the quarter wouldn't fit, but we can now reload from, if it lets me do it, reload from disk, and then okay, this will now fit. This is 1/6 of the the thing. Look at that. Oh wow. Weird. Maybe there would be like, if we have, yeah, if we had like some thing to align it, but well, we can't get everything made perfect here. We can even print 2 at once if we would like to. So how does that? That's the textured pie plate. How long does that print? I think I have, let me check what, 0.2 millimeter is really slow. But I think I have 0. Oh, I can't see. I might have 0.2 millimeters in there, if I didn't change it again. Okay, standard, flow, PLA, basic. Yeah, I think I have. We can try printing in black here. So let's. Oh, yeah. Hey Ray. Let's test how that does. Alright, that takes 6 hours. Okay, let me change my profile. This is not good. It's way too slow. I need to print so many of those. It wouldn't be finished this week. Okay, what about 0.8 millimeters? Yeah, 1 hour. That sounds great. But the 0.8 millimeter nozzle is currently mounted on. Yeah, we can change the nozzle and do that. That looks like. I guess that will work. Hey, Jesse Harry. Oh, we need 6 of those, not only 4. We can try prepare. A lot of this is preparation. So copy. Where is it? Mirror. No, centers. Fix. Clone and clone 5 times. I think we can print 3 at once. Ah! What would happen if we print 3 at once? It's so weird. It looks like it's off. I guess we would need like to optimize the placement. Let's just see how that slices. Is it? Yeah, we only save like 15 minutes. But we don't save anything because if one detaches, all the prints are broken. So I don't take the risk unless I'm going to bed and leave it print overnight. So I will just print 1 now, and let's switch the nozzle then. Oh yeah, that will be interesting. Do we have a nozzle here? Oh, yeah. Let's take a look. What kind of nozzles do we have? We have... Oh, I don't know if we have 0.8 here. Yes, we have 0.8 nozzle here. But it's like a partial... It's only the nozzle. No, it's nozzle with fan and everything. I hope this is the right one for... Yeah, that is the nozzle for this printer. Hey, the Sheepu! The Sheepu, a real talk about Open Hardware Summit. I'm still not sure if I can go. Yesterday I had a mega rant about the public transport, which they want like 200 euros from me to go back and forth. It's like twice as expensive as going alone by car. So I will see how my project proceeds, and if I have it ready, so we can code the ultra cluster at the weekend, then I will put it in my... Look at the PCB, the Shippo. Now parking fees are not relevant. They're like $10 a night or something. I don't care about parking fees. I will park somewhere and then go on the public transport. That's not an issue. I can do park and ride or whatever. Look at the PCB size. So I I need to assemble this and put it in the car, and then we can program it. But this is okay. But now we need to switch the nozzle first. So let's do that. You can roll it there. Yeah, I have 5 of those. Since you can only order quantities of 5, I need only 1 to assemble the first version, and I have 4 spares for building a car. Okay, yeah, let's switch to this camera, and then we can see how to set up the camera first, and then we will do some space here. Switching the nozzle on stream. Yeah. show. My tripod. Oh, this will work. What? You have a room? That's convincing. I mean, we can share the cost, or because I didn't take care of that at all right now. I'm really super spontaneous. I had so much stress lately that I only want to go if I don't break off a leg. You would say that in German, but okay, I will clean that thing. Oh wait, you're not seeing anything. Oh! Camera. Yeah, I can fit 3 or 4 on the plate. No worries about that. I just don't want right now. I don't want to risk if one fails or something to risk like 4 hours of print. Okay, new firmware. Yeah, okay, you can load new firmware. I don't want to remove the AMS. I can print so. Oh yeah, okay, we can print 2, but you want a quick stream, so we will see only. Okay, yeah. Let's remove that. Can you even see anything? No, you can't. This tripod is not what we need here. Ah! How do I? Yeah, I will take the camera off the tripod. Sorry, barf can, and put it on something. Oh. Yeah, just put it. I put it on a PC card. A stack of PC cards. So this is my new tripod here. Nope. Not good enough. I need more PC cards or connectors to stack. I need some parts here. This is now a good view. All right. This is the wrong tool. Give me the right tool here. Oh no. Is it even here? The printer. We are breaking the printer today. Switching the nozzle to 0.8. I might need to, I don't know if, do we need to heat it up? No. I hope not. Oh wait, I had tools here. Let me take this one. Start a fire. Okay. That's 2. Yeah. I switched, I think this is 0.2 right now, so I have switched it before. Just need to get the right size tool size here. Huh? The light is so dim. Weird. I don't have the right size tool here. Okay, I'll be back in a second. Let me grab my tools. Okay. I'm back. Oh, here it is. This was the right Allen key. Maybe this side. And maybe this size. Oh, that works. Can we get some more lights in here? this one doesn't work. Oh man, it's ridiculous. They're discharging. Yeah, they discharged by the phone. Alright, no light then. On battery lights. Am I missing something? Here we go. Nice. And we need to disconnect these things here. We don't want to rip off connector. Here we go. So that was a nozzle of 0.2. Yeah, now we're having 0.8 for a change. How does it, where those cables are? What was the cable management here? If I press it in like that, it doesn't fit. Okay, huh? That might fit, but this T2 won't. Okay. Nope. Okay, the cables are really weird here. Or is this wrong size? No, wrong side. This was the right side, was it? Something's... Was it this way around? No. No, this is this way. This is painful. Okay, yeah, I need to really squeeze it to get the cables in there. Okay, bolts are in. That's everything that matters. Taking the time to switch the nozzle is totally worth it if you consider that it takes 1/4 of the time to print each part. I hope the fitting is still alright though. Which way around is it? I hope this way. Oh, wrong way. I think this was wrong. First of all, I will do this. This is clear. But this JST. Okay, it's in. All right. Let's squeeze the cables in. Maybe not in front of the fan. Like that. Put that on. And we are done. The camera was totally off. Okay, I will clean the bed while it's updating. It runs a software update. And then we can start printing it. Yeah. Americans would call it Windex. Just a window cleaner or glass Glasreiniger. Needs to be free from fat. Any grease needs to be gone, so everything sticks nicely. All right. Oh no, why is the update so slow? Still downloading? Oh no. I shouldn't have started it. What is it downloading? It hangs at 1%. Does it even have a connection? You know what? I will turn it off. Okay. Yeah. I won't anymore. Okay, camera needs to go on tripod again. Before I step on it, because I'm slob. Now I bricked it. Completely. Uh-oh. Now, light turned on. Nope, let's not update right now. Alright. Let's try to print it with the new nozzle. Standard flow. Yeah, let's just slice the plate and print plate. I hope it's still connected to the webs. External? No. Time synchronization timeout? What? What's going on? Wi-Fi? Who's there? Hey Alex! Are you in Berlin already? You also going to Open Hardware Summit? Okay, let's try other Wi-Fi. What do you mean next week? I mean, is it not like next weekend? Open Hardware Summit, or what is next week? Did I miss something? Again? Nozzle type. Yeah, from Friday. I'm not sure yet. I would need to go by car because Deutsche Bahn is trying to rip me off. Even the Bahn card doesn't make it cheap. So, and I have a big. Let me print calibration settings. I have a big device, hopefully to bring and show. Oh, you're in Munich. What did you do in Munich? Just visiting Alex, or any occasion, a special occasion? Did I miss like Electronica or something? No, Electronica should be later this year. Should it? I don't know. No. Where's the settings for the print options? I think the nozzle. What is this? User information has expired. Please log in again. Oh, that's cool. Road trip is amazing. Love road trips. Why is it so hard to print anything nowadays? Okay, status X1 carbon. Connecting. It's not connecting anymore. Okay, I probably need to reconnect it because it says my login information expired. Bastards. Alright. Huh? Früher war alles besser, ja. What does it say? User log in. Where do I log in? Okay, let's do LAN mode then. Settings. LAN only. Okay, LAN on confirm. Okay, very good. Now, but do I need like to rediscover the printer? I hope not. Pin code, okay. Account page, printer screen. Oh, damn it. Yeah, let me do the access code thing. Oh, do I really need the IP as well? And the IP is on a different page on the printer? Thank you very much for nothing. Why is it so annoying? Okay, settings. Here, 140. Yeah, found it. Ah. Enshittification is real, people. I just want G-code over serial. Okay, now we have device connected. Is it connected though? Come on. Storage needs to be inserted before printing via LAN. Ah! I don't have an SD card in there. Okay. Now it's probably also picky about the SD card. Where are my SD cards? In this chaos here. Okay, let's see. What do we have? Some. That's 32 gigs. 8 gigs. Now it probably complains about the format. Format required. Okay, let's format the storage. Might be a broken card though, I have no clue what's on there. I don't care, I just delete everything now. Yeah, this takes suspiciously long. I will just throw it in the garbage when this SD card doesn't work. Every SD card that doesn't work, I will just throw in the garbage. What else do we have? We have here another Transcend and oh, this one! Lexar. I think this one was shipped with a 3D printer. Yeah, it's not formatting. All the formatting takes too long. Orca slicer. Is this good with Bumble Lab printers? Okay, yeah, that's not formatting. It died. It hangs. I think this SD card was faulty. Oh, that's cool. Didn't know that. Oh yeah, I think I saw like that the Bumble Lab studio is open source. That makes sense. Alright. Storage. Okay, yeah, storage is working. I just used to. I need to check if this card is like really faulty, so I will just throw it away. There's no time. That's wrong. That's wrong. Diameter. Do I need to set the nozzle size in? Okay, I think I need to change in the settings the nozzle size, but I didn't find it yet. Chamber motion. Settings. Yeah, but where's the setting in the? I can't find it. I can't find the setting on the printer. Nozzle extruder. Oh yeah, here it is. Okay, found it. Ah, here we go. All right. Refresh. That's wrong, my friends. That's wrong. Doesn't show. Here we go. Send. That took me half an hour. It's still not printing. Let's wait and see what happens. I might also need more filament. Not sure if that kilogram that I have there. Time-lapse Bible thumb. Yeah, alright. No updates then. Okay, it says storage needs to be inserted 100%. Okay, is it doing anything? What is it doing now? It doesn't look like it. Yeah, it shows 18.9 gigs of 29.5. Alright, print files. There are even files on that card. No, internal SD card. Yeah, there is stuff on the SD card. Oh, this is so weird. Yeah, I guess so. Or let me try again. Oh no. Yeah. Okay. I will also restart the printer. The timing, nice. Yeah, hotfix, blah blah blah. Blah blah blah, Mr. Freeman. Carbon, texture, pay, blah. C3, don't connect to Wi-Fi. Yumbo. I have no clue. What's going on there? Did you try any like firmware where you discover networks or whatever? I know what's the some sort of Wi-Fi. No printer. Okay, we are connected. Yeah, I would try to see if it even lists open network, or not open, just lists the network, so you know Wi-Fi is working at all. And you have maybe, I don't know, that there is. Okay, let's try again. Now it shows everything on send. Ah, here we go. Ah, some global variables or stored state or shit. Ain't nobody got time for that. C3, is it like 5G or 2.4? Okay, it wouldn't recognize the Wi-Fi. I think C3 even supports 5G network. It's weird. 2.4, okay. That should be supported by any. Let's turn on the camera, can we? Play. Let's see if it does anything. It moves, yeah. Okay, we have like another, I want to stream another 20 minutes. Shall we try assembling one of the power boards? At least like reflowing that. We had quite a quick and good stream yesterday doing that. Where is the stencil for that? Uh-oh. I hope I didn't discard the stencil. Okay, you can see it though. Ah! Let's see. There it is. We can make assembly of the power board, or at least a reflow one. And we definitely need like a jig for that, because that was needed to be assembled several times. Okay, well, I had like one brick flying around here. If I can find all the parts, we will do it. Otherwise, I won't start a new thing today, and we will just finish the designs for the 3D printing part, and then continue tomorrow. I can stream now. I think I will stream more often, not only on Wednesday. I'm not sure if tomorrow, but I will try. If so, there should be an announcement on YouTube several hours beforehand. Okay, I have some connectors here, that's some parts. Okay, these are 22 microfarad capacitors, 25 volts, so they're the input side caps. Not sure how many I planned to use there. Then we have some of the JST connectors. JST. We need a trimmer. A series. Really? Oh. Oh, presence sensors. That's what I was thinking today about, like if I want to place like some control, presence sensor control for lights in my home, but not connected over Wi-Fi, just standalone. Okay, I think. Yeah, these are the output caps. Terahertz radiation, that would be interesting. 6.3. Okay, yeah, that's the output caps, I believe. What's one thing that I'm like in my living room, there is a window just behind the sofa. Okay, now it's doing the vibration test. Behind the sofa, and whenever it's afternoon, the sun is shining and we have like gloss on the TV, and I want the oh wait a second, look at that, the pink connectors. Sweet. That's the pink SATA connectors, and we don't have a use for the SATA yet. I bought so many SATA cables. And these are the other SATA connectors. Okay, so we found that. We need to open the Reichelt box. With, I think they are the trimmers inside, if I didn't buy them. Where were the trimmers? Because if you don't have trimmers, I don't need to do anything. Need more packaging material. More. Oh no, these are the. Okay. These are the 2mm headers. I bought some from Reichelt because they shipped quicker. We need those for the main PCB here and there. This is USB, and the USB port is an external, just USB 2, because the smaller, I think it has enough bandwidth. Does it have? I don't know. I bought, I think, even USB 3 connectors. Where is that? I lost them. External ones, and we can connect it via that. But this is not what I want. I want trimmers. Anyways, we don't need the trimmers for the assembly on that. I will just make the jig right now while we are waiting for the other stuff to print. Okay, JLC carton. It's my jig. three PCBs serve as the frame. They are a little bit thicker because I took 4 layers of heavy copper. They feel really heavy as well. That's a lot of copper because we trying to handle a lot of current here. Oh, I don't think this will fit on my cardboard here. Yeah, might. Oh, that prints quick. Look at that. Whoop. That's a thick line. And not wasting any time here. How much infill does it have? I didn't even check. Not that it's like solid. Infill. Oh, sparse. Yeah, but this wall strength is should be plenty strength here. Okay, let's make the jig then. I will use the bigger camera again to share every step of that with you. Oh no, I pulled off the cable. Okay. There we go. You're joking. What did it do? Why did it have like a pause there? Weird. No, there's like debris. You mean this here? All right. Pause and clean. Probably because the first layer is always a little bit variation in height, and after that, it's better. I have no clue. Might be. Okay, Captain Tape. We used it yesterday. There it is. This is our jig. Oh, I'm not sharing. Ah, okay. Need to get this aligned properly, like right angle. Now this. I think this will be good enough for our stencil. I don't know, I bought it 10 years ago and I still have enough of that. I use that to, usually you use that in the beginnings of the printing times to print ABS. So that's that little story. Now where is... Huh? Where did I put the... Here. Just the stencil. Stencil is here. Alright. Oh yeah. Forgot about that one. The huge cap needs to go in between there. Doesn't need, but can go there. This is shitty. Ah, good enough. Okay. Whoop, whoop. Oh, the board's going out. Look at that. Perfect. Okay, maybe I should use... No, I don't want to... I mean, the power supply should never exceed 140 degrees C, so... Barf cam activated. Ah! The chaos here. The chaos is real. Okay, yesterday I used a little bit of stencil as the spatula. There is still some paste from yesterday, and I think this is still good. No, it's not. Okay, let's get new paste then. But actually, it's not bad. It's not water based, so let's try to. Is the reflection bad? Let's try to paste that. Yeah, it's a little bit, it feels too thick, especially on the big pads. Ta-da! Nope. Here it is. These pads have not enough paste. Here, now it's good. Alright. That's that. Hocus focus. Hocus focus! Damn it. Here we go. Yeah, good enough. Let's see if we can place the components. Oh, it's 8 o'clock. Oh no! Stream should end now. It's Tagesschau time. Wee, 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 wee. Check something. We have a few more minutes, I believe. Okay. So, this is the main culprit. Cute little device. You need a good connection. Yeah, look at that. Yeah, it's sticking well. And then we need a ton of caps and everything. Oh no, I didn't. Yeah, I don't need to populate that though. I just need the input and output caps and that's it. So let's do that, and I hope I have enough. Have all the stuff here. Did I mark it even? Let me check if I. Oh, let's see. Because I might need like different caps for input output. I have no markings about what type we need there. These here and these here. Hey cosine, you're a little bit late. I'm just about like to reflow that one and be good. We are trying to assemble the ultra cluster. Maybe I will use the reflow oven here, but I'm trying to load the power board now. I need to check to not miss anything crucial here. Where are the caps still? I can. So many parts. I think that input caps are optional. So, all right, power boards. Let's see. So this is 22, 22, 22, 22, and these are all 100, yeah. 100, 100, 100, 100, 100, 100, 100. All right. So there is no surprises there. We will just place the caps and be good for today, huh? Oops. All right. Need to be sure that I place the right ones here. The 25 volts needs to go here. Any other small things? Oh no, I need to place the other components as well. There are some. For I think 0 ohms there as well, but I should have them here. So let's do the biggies first. Need 4 of those. Right. Ah! Come on. This is sticky. Like that. Alright. Now this was that one. Let's do the 100 nanofarads. I will full reel of that. Oh, there's a stray one. Interesting. A pick and place machine now. This is a power regulator. It converts 12 volts to 3.3 volts or any other voltage, because we will use a trimmer for that. Okay, I need less sticky. I'll clean my tweezers because they are sticky with IPA. Hold on. It's quite hefty because it's rated for 30 amps. We will use it at 20 amps. So, and then it's still like 95% efficient. We have space for a heatsink on the back. That's why it takes a few of those caps here. I used only 4 at 2 ounces. Also the inner layers. Was it 1 ounce? I don't know. Like double. I hope it can handle that. We will see. Oh no, I smeared that one already here. That's not so crucial because that's optional part here. I added like some extra control for fan control, PWM fan control, and so on. So, but we only need to populate several things. I need to check what else is crucial, and then we will refill that. Okay, sense. Huh? Oh no, okay. I actually need a transistor here, power good transistor. So I need to check that off stream, but I will reflow it for now because we can add R1 and R11. I don't see the values though, that's weird. Is this like 0 ohms or what is it? 0 ohms, alright. R1 and R11 are 0 ohms. Okay, 0 ohms. R13. Zero ohms. 11, 12, 13. Oh no, 12 is unpopulated. It's 11 and 13, I believe. 11 can be anything else than as a safety. Okay. We need 1 and 13 to be placed right now. One and 13. Okay, let's do that. We have that here, 0 ohms. If not, I will just populate it later because, oh well, what can you do? Yeah, I don't see it here. It's only like standard values, but no 0 ohms. Okay, you know what? Let's reflow that, and I will solder on. We will continue. I will either solder on tomorrow, or we will continue together tomorrow on stream. All right. So let's reflow that, and then be good. Just to have something reflow, not only 3D printing today. I want to see it too. Okay, bath cam. More mode activated. Oh, yeah, fingers crossed. It will be weird because this is like quite heavy on copper. That's why I'm using the bigger, slightly bigger thing here. But it's a low temp paste, so I'm not really worried. Give it to me, baby. Alright. Very condensed stream today. Except for the struggle setting up the printer. Alright. It's 31. Okay, let's wait a little bit before I record actually. I do 160 degrees, this should be fine. Okay, it's now at 100. Now it's starting to reflow. It's cooking. Let's poke it and see if it hovers. Yeah, that's a good sign. So we should have a good connection there. I will just turn it off. All the caps are good, not wood stoning. Everything looking great. Even with the old paste. Yeah, no. It's 160 degrees, fine. It doesn't even stink. But testing is tomorrow. today we're done with that. I will just wait for it to be finished here. And maybe we have even ready looks like, oh, what? 25 more minutes? Yeah, we won't see that being finished. I thought it is only like 1 hour print. Didn't we start like already 50 minutes ago? Yeah, I have an appointment. I need to go now. Peeps, that should be it for today. Let me check if the board is done. We won't be waiting for the print to be finished. I will stream tomorrow at 6 o'clock p.m. again, maybe? How about that? Just before the hangout. We will do some hangout later, and then at 8 o'clock, so we have another 2 hours. Yeah, at 0.8 is a stretch. Alright, bye bye everyone, see you tomorrow then. Oh wait, let's see for that. We can. Is it still hot? Oh, it's still hot. Yeah, it's still hot. Yeah, but I will take it off and let's see. Before I say goodbye. Yeah, it is solidified already. Yeah, not touching that. Yeah. Solidified already, but it's still hot. And this is, yeah, I know. Here we go. That's that. See you tomorrow. I will see if I can either finish that. Interesting part. On the back side, we with some thermal pad, we can cool it down then here. This is extra for that, and we have plenty of vias. Look at that. I didn't plug the vias to have that filled with copper, but I think it is still this sort of it's so hot. Like that. Hope it fits in the end. It's weird. Is it that? Yeah. Cool, huh? Alright. See you tomorrow, peeps. Bye bye.